All right, we're going to try lesson 5, the Pythagorean theorem. We've done this probably in Algebra 1, Algebra 2, the whole way up. They present it a little bit differently. Some of the stuff is kind of crazy that they do. So you can always just revert back to what we learned in the past. Theorem 52 is the Pythagorean theorem that says in a right triangle, the squares of the hypotenuse is equal to the sums of the squares of the legs. And all that's saying is if you have a right triangle, let me draw us a right triangle here. If you have a right triangle, here's our right triangle. And if this is the right angle right there, obviously. This is a leg, and this is called your hypotenuse. So we typically call the legs A and B. I'm just starting with the basics in case you didn't have this before. And the hypotenuse is the one opposite the right angle, and that's called C. What it's just saying, in a right triangle, the squares of the hypotenuse, the square of the hypotenuse is equal to the sum of the squares of the legs. So all it's saying here is A squared plus B squared, that's the two legs, equals the square of the hypotenuse. Usually we do A squared plus B squared equals C squared instead of C squared equals A squared plus B squared. So that's basically all it's saying. If we look, I'm not going to prove this theorem, it's in your book if you want to look at it, it's kind of complicated. But if we look over here, here's a picture from your book. What it's saying is this is your hypotenuse right here. This would be A, this is B. If we square A, so this would be whatever A is, it would be 3. If we square it, it's 9. And this is B, which is 4 blocks. If we square it, it would be 16. If we add those blocks together, it equals 25 blocks, which would be the square of this one. It's just kind of cool to see the visual of it. They try to use this visual a lot, and I'm not sure that it makes as much sense as just using this formula. So let's get down here. Let's try this one right here, and maybe we'll try another one too, just to help you understand it. Let's start. You know what? Let's start with an easier version of this, more straightforward. Let me just make another right triangle. If I can do that, let's see. Let's just do another right triangle. That one's kind of cool. Look at that, different colors. All right, let's fill in numbers for it. Let's just pick some random numbers here. Let's make, trying to make this easy. Let's do 2. Let's make this one 2, this one 6, and this one x. So say we want to find out what x is. Here's our right angle. These are the legs. So to find out x, that would be our c. So we just put in this formula, a squared, which would be either one of these. You can call this one a or this one a. So let's just do 2 squared plus 6 squared equals whatever x squared is. Because we have, remember the hypotenuse is the c. So we're going to get 4 plus 36 equals x squared. We add those together, we get 40 equals x squared. And then to get x by itself, you take the square root of both sides. And you would get x equals, I'm just going to switch those, and it would be the square root of 40, but we don't leave it like that. The biggest square that would go into that would be 4, so we get 2 square root of 10. So that would be the side, this side. That one's a straightforward one because you just plug it in and get this one out. Hopefully this doesn't mess too many of you guys up. Okay, let's look at one more of these. Here we have, this time we don't know what either A or B is. We'll just call that we don't know what B is. So when we put it into our formula where the B is, we're going to put the x. So let's try that. So we get a squared. Remember, these are the legs. The hypotenuse is opposite the right angle. So we're going to call this one a. 16 squared plus x squared, that's our b, equals 34 squared. And when we multiply that out, we're going to get 16 squared would be 256. plus x squared. And if we did 34 squared, it's 1156, 1156. If we get x by itself, we get x squared. And if I subtract 256 from both sides, we get 900. We've got some algebra going on here, so if some of you have trouble with your algebra, you might need to get some extra help on this. Equals 30. So we solve for x. These are pretty straightforward. So if you're listening to this video, you have permission just to do the odd problems. And people that didn't watch the video, well, I guess they have to do them all. So let's move over here and let's look at the other theorem that's in the book. The other theorem says if the square of one side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. So what we're saying here, basically, is that if this holds true, if a squared plus b squared does equal c squared, then it is a right triangle, even if you didn't know it was a right triangle. So I don't know where that will come into play, but it might. So if we have x equals 30, if you did this, you did 30 squared plus 16 squared, and if you find out if it equals 34 squared, then you can say it's a right triangle. The other way around is they said it's a right triangle, and you define the missing part. So let's look at another, two more quick examples. These are kind of silly in your book, so we'll do this one the way they want you to do it, and we'll do this way the way I think it's easier. This one here, they just give us this one side is 14. In this case, there's only one way to do it, because they don't give us enough numbers. They don't give us any of the sides. But if we look at this picture over here, whoops, we know that this bigger square is whatever this is squared and this is squared. So what that tells me is we figure out 14 squared. Whoops, I'm using a calculator here. 14 times 14 is 256, or 196. So that tells us, let's see what we're looking for real quick. It says find the shaded area. So we know that this plus this equals whatever this is squared. And this squared is 196. 196. So we know these two red squares have to equal 196. So these two, we don't even care what these sides are. We know that this plus this has to equal 196. I think it's a little confusing. So you can see here, this square and this square, if you add those two up, 9 and 16, you're going to get the big one. So what we did here is we figured out the big one, so we knew that the two red ones added together is 196. So I hope that made sense. Now I'm going to do it differently for the final example. They do the same square thing. If you understand how these square things work, go for it. But what I would do here is you have the two legs and you have to find the hypotenuse. So we're going to get 4 squared plus 8 squared equals c squared. We don't have anything on that, so we'll just label that c. So I'm going to find the sides of the triangles, and I'm going to find out that this one, 16 plus 64 equals c squared. So we get 80 equals c squared. So we're going to find out that c equals the square root of 80. We can leave that there for a minute. And then they want to know the area of the red part. So what we need to do is find the area of the red, the whole thing, the whole square, and then subtract off the triangle. So if we want to find the area of the whole square, it's going to be c squared. So the area of quadrilateral FIRE is equal to the square root of 80 squared, because to find the area of a square, we have to square one of the sides. So we're going to get that the area of that square equals 80. And then we have to subtract off the area of the triangle. So that would be 1/2, and then it would be base times height. The height would be the altitude, which would be the right angle. So it would be 8 times 4. So we would subtract that off, and we would get 80 minus 16. And so we would get the area of that one. This is number 19. Is 64. They do it some other way where so you might have trouble finding your answers. They use the squares that come off of it. So that's your final answer for that. Hopefully these won't be too difficult just because of the way they do it. So it's just Pythagorean theorem. Do your best. We're going to work on this tomorrow or today. I'm doing this Tuesday night. But make sure if you don't get these that you go to the help board and get help with these before class. We're not going to have much time to go over homework in class. So that's it for lesson 5.